We're going to move on and we're going to talk about reading binary files. So in this class, at least twice, I'm going to be expecting you to read binary files. One of them is for the first assignment that will be posted soon, and then the other is going to be for the last assignment. In terms of working with binary files, there are two main strategies that you can use to do this. One is to do something called overlaying structs, where you define a struct and then you just read directly into that struct. And then the other one is going to be parsing. So reading the binary file kind of byte by byte and loading it into properties of a struct that you have defined. What I want to do is parse a bitmap header. So a bitmap file header. I'm going to start this by opening Paint, and I'm going to draw a picture. Okay, there's my artwork. I'm going to save it. I'm going to save it to this folder, and I'm going to make sure that I actually pick a bitmap file here. I'm going to make it a monochrome bitmap. You know, we only need so many colors to represent this. So I'm going to save this file. I'll share this file with you just to make sure that everybody has a copy of it. It's important to have this file. I'm going to lose some quality, but I think that's okay. And then I'm going to close it. I'll move it over so we can, you know, look at it again later. So I've got my canonical source of information here, which is the Wikipedia article for the bitmap file format. The bitmap file format is more complicated than I expected it to be. It is a lot more complicated than I expected it to be. We're not parsing an entire bitmap format. So you can see on the right side of my screen here, this is kind of an image that describes the entire bitmap format. And in that you can see that there are different colors and a lot of arrows in this thing. It's a lot more complicated than I expected it to be. Don't worry about it. We're not going to be parsing all of that stuff. The only thing that I really care about right now is what's in this table here, the bitmap file header. This is the only thing that I care about right now. So in the bitmap file header, this is going to be the first 14 bytes of the file. This is going to be the first 14 bytes of the file that we're going to be working with. And this defines some information about the bitmap itself. So what I'm going to do is move this to the side, and then I'm going to open up a file that I've got here called binread.c, where I've kind of got some starting point for this. What I want to do is start defining a struct for this file format. So I've got some basic stuff. I've got my main definition. I've got, you know, stdio and stdlib. I'm going to get my file name. So my file name here is file name is equal to, I called it untitled.bmp. So that's my file name. And I've got, I got to move it into this directory so that I have access to it. So I've got my file name, I've got my main, and I've got a couple of extra things here. I'm going to start by defining a struct. So I'm going to say type def struct bmp header. And the way that I'm going to define this struct is by taking a look at this table that we've got on the right side. So this table tells us exactly how many bytes each of these different parts of the header take. The first thing here is called the header field. It takes 2 bytes. The next thing is the size of the bitmap in bytes. It takes 4 bytes. Then there's a couple of reserved things that are each 2 bytes. And then finally, there's 4 bytes for an offset. This is the starting address of where the bitmap data actually begins. So I'm going to start by defining the the bytes that I need to use for that part of the header. The way that I'm going to do this in general is I'm going to use this class of things called the uint_xt. There's 2 bytes here, so I want to have 16 bits to represent this. So I'm going to say uint16t header field. That's going to be exactly 2 bytes. And to get access to these, I need to number include stdint.h that defines all of these. The purpose of using these is that I don't have to know what the underlying system actually uses to represent 16 bits. I can just say I want 16 bits, and then the program that I have will be compiled properly with the number of bits that I want for that. So I've got header field, uint16t header field. The next one is the size of the bitmap file in bytes, which is 4 bytes. So I'm going to say uint32t file size. There's two things that are reserved here. I don't really care about those very much. And then there's the last one here is the offset. So where the data actually starts, which is also 4 bytes. So uint32t. I'll call this data offset. Okay. So I've got everything that I need here. I'm going to change one thing here. This tells me that it's actually putting these 2 bytes in ASCII. So I'm going to change this instead of being a single 16-bit field. I'm going to change this to be an unsigned char that's 2 bytes wide. So each character is 2 bytes wide. Each character is 1 byte wide, and I have 2 of them. Now that I've got my struct defined, I can start actually reading this in. So the way that you have worked with files before is to use the standard IO functions, fopen and then fgets. So I'm going to take a quick look here at the man page for fgets. The way that fgets works is that we pass it a file pointer. That's what we get back from fopen. We give it the size, the number of bytes that we want it to read. Then we give it a buffer that points to what we want it to read into. This is good for reading text files, but it's not going to be great for reading binary files. So we are not going to be using fopen and fgets to do this, but instead we're going to be using some of the lower level system calls to work with binary files. So instead of fgets and fopen, we're going to be using the low level system call open. So to get information about that, I need to use, so I'll type this more slowly, man2open. If you just do man open, what you're going to get is a command called open. But we want to know about the system call open. So we have to say man2open. That gives us the section 2 manual page for the system call open. All system calls are under this section 2 for manual pages. So I'm going to use this system call to do that. This tells us about how we actually open the file. The one that we really care about here is this first version of it, which lets us specify a path name. So it's the same as what we would normally expect. This is the path to the file. It's a string, a null terminated string. And then it gives us some flags that we need to use to try and read this file. So I'm going to say here int file descriptor. I'm going to say int bitmap file descriptor. So bmpfd is equal to open. I'm going to pass to it the file name. And what I'm going to now pass to open is some flags that we want for this. In the open manual page, what you're going to find is that there's a bunch of different flags, but the argument flags must include one of the following access modes. We only care about reading, so we're going to pass the flag read-only. But each of these will let you do things like open it for reading, open it for writing, or open it for both. In this case, we only really care about opening it for reading, so we're going to say read-only. So this is going to let us open the file. Let's try compiling this now. So I'm going to say make bin read. And immediately we can't do anything with this because we have to bring in some things. So let's take a look at that man page again. And it tells us which headers we need to include to be able to get access to the open system call. So let's add those to the start of our program here. I think that should be all that I need for this. Let's try compile it again. Okay, good. That's all we need to do this. There's a few listed there, but I think that fcntl.h brings in those other ones as well. All right. So we've got our file open. We've got it as read only, and we have now what's called a file descriptor. So this is an integer. So this is not a pointer. This is very explicitly not a pointer to a file in the same way that fopen returns a pointer to a file. But rather, this is a file descriptor. It's an integer that represents the file that has been opened on our behalf by the operating system. We're going to see this later again, this idea of file descriptors. But the basic idea here is that rather than having pointers with addresses, the operating system is handing out numbers, and you have to give that number back to the operating system when you want to do something with a file, with a specific file or with a specific object. It's kind of the same idea as a pointer, but it's a little bit different. Depending on when you did comp 2160, if you did the memory manager, you may have actually done something like this. So rather than giving out pointers, you're giving out what are descriptors, so integers to represent a blob of memory that you've assigned. Okay, so the next thing that we need to do is actually read this. Of course, as we've kind of figured out, we can't just fget-s. We can't do that because it's working on an input of characters or an input of string. The s here is coming from string for fgets. So we need to read the bytes from this file, and the way that we're going to do that is using the read system call. So again, we want to refer to the manual pages for this. We want to refer to section 2 for the system calls. And this tells us how to read it, and it's fairly straightforward. So let's go to the top here, and this time I'm going to be smart. I can see that I need to number include something, so I'll number include that right away. Or include uni std. And then I need to actually use that read system call. So the way that I'm going to use the read system call is I'm going to say read. Okay, so great. I have to pass the file descriptor as the first argument here. So bmpfd. I have to pass it a buffer as a second argument. So it's a void pointer, and then I have to pass it the size, the number of bytes that I want it to read. I have to create something to have this read into. So I'm going to create an instance of our struct, bmp header. So I'm going to create an instance of that struct. It's a stack allocated value, and it's been enough space has been allocated on the stack for that object. So now I'm going to pass the address of that. This is taking a pointer to the buffer, so I need to pass an address to that buffer. And I need to tell it how many bytes to read. So I'm going to say size of bmp header. I want you to read that many bytes into this struct. I'm going to save this. I'm going to quit my manual page, and I'm going to make it, make bin read. And if I run bin read now, nothing happens. Nothing happens because I haven't printed anything. I'm not going to bother printing anything, but instead what I'm going to do is use my debugger to help me figure out what is in my file or what's in my struct at any given time. So I'm going to start compiling this manually right now. Clang wall binread.c, binread, and then -g. I want to include debugging symbols. And then I'm going to say lldb binread. The very first thing I need to do here is set a breakpoint. So I'm going to say bmain. And then the next thing I need to do is actually run it, so r. At this point, we have stopped execution in the main function, in the very first line of the main function. I'm going to step over these lines. I'm going to hit next, and then next again, and then next again. So at this point, we've opened it, we've opened the file, we've read bytes into the struct from the file, and we're about to end the program. I'm going to print out my header, and I'm going to print out header field. So I want to see if it's actually read those first 2 bytes correctly. That kind of looks right, BMP. This is a bitmap file, so it sort of seems to make sense. Let's print out header.file size. That does not look right. It's definitely not 0 in size. Let's try to print out header.data offset. Maybe that's right. I don't really know. File size is definitely not right. I'm going to quit my debugger here. I'm going to say ls minus l. My untitled.bmp is 20,702 bytes long. So file size is definitely wrong. That's not right. This is not great because it means that we haven't actually read the things that we want to read. Part of the problem here is that when we define this structure, the compiler is actually free to do whatever it wants with the ordering of those different properties. So even though we've defined the struct in this specific order, the compiler still has the privilege to do things like take data offset and put it first. The compiler can do this without us knowing about it. Most of the time, we don't really care that much because we're referring to these properties by name. We say .data offset and .header field. So we don't usually care very much about this. But as soon as we start trying to read a binary data into a struct, that's broken. If the compiler lays this out differently than we had expected it to, now it's not going to work the way that we wanted it to. So now what we have to do is tell the compiler not to do that. We have to tell the compiler, I have laid this out in a specific way and you should respect that and not change the way that this is laid out. The way that we can do that is using some preprocessor directives. So we're going to say pragma pack, and then push, and then pragma pack, and then 1. This is a little bit of magic. I'm not expecting you to know what this stuff does. All I really care that you know in terms of reading binary files is that this is going to help us stop the compiler from reordering the properties in the struct. And then because we're pushing onto a stack, we also have to say pragma pack pop. There's some Microsoft documentation about these pragmas that I've linked to in the slides themselves, and it gives you an idea of what that looks like, what that actually does, and gives you a little bit more details about it. But again, all I really care is that this helps you tell the compiler not to reorder those properties when it's compiling them. So I'm going to compile this again, changed it. I'm going to do lldb bin read. I'm going to say b main. I'm going to r. I'm going to step over these lines, and I'm going to print out header, header.header field. Okay, so that's still fine. Print out header.file size. Whoops. That's better. That's exactly what we wanted it to be, 20702. And I'm going to print out header.data offset 0. That doesn't seem right. That still doesn't seem right. Data offset tells us where in the file the bitmap data starts. The bitmap data does not start at 0. That's where the header is. So that doesn't seem right. Let's go back to this table here on our right side, and let's add in these 2 bytes for those reserved things. So they come right after file size, and they are both 2 bytes long, so that's 16 bits, uint 16t. and I'll say reserved 1, and then uint16t reserved 2. I'm going to quit, yes, recompile, lldb bmain r n p header dot data offset. That looks a little bit better. So 62 bytes into this file is where the bitmap data actually starts. Let's check again here, p header dot file size. It's still 20702, and p header dot header field, so BMP. So that's great. That's really good. Some of you might be saying to me right now, maybe thinking this in your head, shouting at your screen, I'm not really sure. Some of you might be saying to yourselves right now, this is BMP. That's 3 bytes, not 2 bytes. What's going on? Well, it is 3 bytes, you're right. But this 2 bytes that we've allocated here is not null terminated. So what we're printing out here is the first n bytes until we have a null terminator. And in terms of the way that this structure is laid out, that happens to be in this file size. So there's a bunch of zeros in this file size that are interpreted as a character, which is the null byte. If we're checking this, we would have to say things like, make sure that p header dot header field at position 0 is B and at position 1 is M. That's how we would actually check this, because this isn't really a null terminated string. It's just a blob of characters that we've got. So this is really good. One of the problems with this, though, is that once we have data that is conditional in terms of how it's laid out, so the layout of the data changes based upon certain conditions, like the kind of operating system that you're using or the kind of architecture that you're using, so 32-bit versus 64-bit, for example. When that starts to happen, when the binary format of that file changes based on certain conditions, this is not going to work anymore. We can't just load directly into the instance that we've got. So instead, what we would have to do is parse this file manually. So I'm going to comment out this read right now. And instead, what I'm going to do is start parsing this file instead of just reading it directly into the struct itself. To do that, I'm going to declare and define a couple of functions to help me with that. So I'm going to start here by declaring the function. I'll leave the pragmas. It doesn't really matter ultimately for us right now. But when we're doing parsing, we don't need to have those pragmas. So I'm going to call this function read bitmap header, and what I want to pass to it is a pointer to the header that I want to populate, and I want to pass a handle to it, so a file handle to it. I'm going to copy that. I'm going to paste it down there. And now I'm going to start actually populating this. I want to do a couple of quick checks on this before I start operating in it. So I'm going to say assert that the header is not equal to null. And I'm going to assert that the handle is greater than or equal to 0. I'm going to add assert.h to the beginning of this. And this is just some defensive programming to help make sure that whatever I, as a programmer, am passing to this is not going to crash it without, because I'm passing like a null value to it or something. At this point, I can actually start reading into the file, reading into the struct itself. So I have this instance of a struct, I have the file handle. Instead of reading the entire thing all in one go, I'm going to read each property one at a time. So the very first thing I need to do is read the first 2 bytes. So the first 2 bytes in this header, so these 2 characters, into that header field property of my struct. So I'm going to use my read function, still the same system call. I'm going to pass it handle. I'm going to quit this, yes. The first argument to read is a file handle, file descriptor. The second is the buffer that I want to write into, and then the third is the number of bytes that I want to read. So I'm going to pass it the handle where I wanted to write to is the header at header field, and I want it to read 2 bytes. Let me decompose this line for you here. Header itself is a pointer to a bitmap header. I have to dereference it, so that's that arrow notation, dash and then greater than sign, instead of using dot. But I want to read into that field, so I'm passing it the address of that property of this instance of the struct. So there's a little bit going on there, but it's straightforward. I want to read that header field, it's 2 bytes long. I want to read from the handle, I want to read into header file size, and I want to read 4 bytes this time. So there's exactly 4 bytes for the file size, 2 bytes for the header field, 2 bytes for the file size. I do not care about these reserved values. I don't care about them. So I'm going to skip these bytes, skip the next 4 bytes. I'm going to skip them. I'm not going to read them at all. The way that I'm going to skip those is to use a function called lseek. So I'm going to go man to lseek. And the way that lseek works is it takes 3 arguments. The first is the file descriptor that you want it to operate on. The next is an offset. So this is how many bytes you want it to skip or seek. And then the third is called whence. The whence field here is where you want it to start from, where you want it to start skipping from. Let's look a little bit further down here. Specifically, I want to look at the whence value. Whence sounds like Old English. Whence here says it must be one of these 3 values: seek set, seek cur, or seek end. Seek set says the file offset is set to offset bytes. So this means that we're going to put the file descriptor, we're going to have it pointing at from the start of the file this many bytes away. Seek cur says from the current location add this many bytes to it. And then seek end is go past the end of the file. We are interested in seek cur right now. The choice here is seek set and seek cur, and we're way more interested in seek cur. We want to skip these 4 bytes after we have read this 4 bytes. So I'm going to say here, skip the next 4 bytes, lseek, handle, and then I want to skip 4 bytes, and I want to start at seek cur. So the current location from where I'm currently reading. Finally, I want to actually read the 4 bytes for the offset. So here I'm now going to say read, handle, header, offset. And then I want to read 4 bytes. Did I call it offset or data offset? Data offset. So I'm going to compile this. On line 25, header is unused. Oops, I forgot to call my function. Haha. Okay, so then I'm going to call my function, read BMP header. I'm going to pass to it my header, and I'm going to pass to it the handle. And this is not handle, but BMPFT. There we go. So that's better. And then I'm going to LLDB bin read. I'm going to B. Instead of B main this time, I'm going to break in read BMP header. And I'm going to run it. So I'm going to check here. What does header currently look like? Header is this address. I'm going to say, what's header at header field? It should be nothing. It should be kind of the empty string. I'm going to say px. So that says printed as hex, but it's also still just nothing. I'm going to say p header at data offset. That's some random value. So this is a struct that hasn't been initialized yet, so it's kind of got a bunch of random garbage in it. So I'm going to step through this function. I'm going to print out now. So after I've read it, I'm going to print out header field. So that's BM. So this time we're not skipping to the P. I'm going to run the next line, p header file size 20702, and I bet if I say p header at header field now, it's going to be BMP again. Yeah. Okay, so I'm going to skip the next 4 bytes, and I'm going to read that data offset. So p header data offset, and that gives me 62. So that's where the bitmap data actually starts. So that's the end of my little coding session here. The useful syscalls that you need to know about to do this are open, and again, you need to see section 2 of the man pages for this. So man to open, read, so man to read, and lseek, so man to lseek. This pragma pack, this is a link that you can click on that will take you to the Microsoft Visual Studio documentation that describes this pragma. But again, all you really need to know is that that little magic that I have in the file that I'm going to provide to you will tell the compiler not to reorder the properties of your struct. And then finally, uint_xt. So these are going to be predefined types that will occupy or require or take, or however you want to describe it, exactly x bits. So you don't need to know or care how many bits wide a short is versus a long versus an int. You can take a look at man_stdint.h to see all of the different listings of the different kinds that you have for this. So that's it for this code. I will put this up on the course webpage. To be clear, you should not copy this code in any way, shape, or form. You're welcome to use it to inspire you in the code that you're going to write, but you should not be copying my code, especially because you're not going to be reading bitmap files. That's it for now. I hope this is helpful, and I hope you all have a good weekend. Bye.